This is a Dell laptop here, and actually this video is just meant to explain what we mean by low logic and high logic. I mean what we mean by that hash that used to be at the back of signal. We have, when for instance now, when you are at the charging section, there is this signal that used to be ACOK in another board, and you find it in another board to be ACOK hash. So if, let me get a pen, you can get pen, you can àti biro kan. Kan ṣàlàyé by video basically ó dá lé lórí nǹkan tá mean by AC, nǹkan tá mean by hash signal, tá mean by low logic, high logic. And basically let me just use this section as an example. If you are at the charging section, you must have noticed some signal that comes like this. ACOK 1 and ACOK hash. At times it used to be ACOK or AC present, AC press, PRS, and it's going to have bar. This bar means hash signal. So basically what we are trying to explain here is, you know, in that charging section, if you should have ACOK here, just plain ACOK without the hash signal, it means it is going to activate whenever this signal is at 3 volt, that is high logic. I mean whenever the logic is high, it is going to activate, and it will deactivate whenever the logic is what is low. Probably we should have 0 volts. Kí mo sọ ń báyìí, tẹ́ bá wo charging section yẹn, ACOK tó máa ń wá ní tí ò ní hash nínú àti ACOK tó ní hash nínú. Basically ACOK tí kò ní hash yìí òun ló ń pè ní high logic, èyí tó ní hash là ń pè ní low logic. High logic that means ni pé ó máa activate, ó means pé ibẹ̀ yẹn ti wà okay with higher signal ní case eléyìí, ó dẹ̀ means pé ibẹ̀ yẹn ti wà okay with lower signal ní case eléyìí. Basically nǹkan tí video ìfẹ́ dá lé lórí nìyẹn. And coming back to this part here, this is a keyboard light system here, and they've changed this keyboard. They now said this keyboard is not turning on. The number one clue here is they only changed this, what's it called, this light from the previous one and bring it down here, and they said it is not turning on. On the old board, old board here, old keyboard you want buy. On the old keyboard, this F10 here, it has that symbol of LED light. The person must have not noticed that. And yeah, actually this is not a big deal. I just want to use this avenue to explain low logic, high logic, and co. If I'm able to get this old keyboard, they will bring it before I finish this video. Yeah, number one thing is to confirm if this keyboard light is still working. I mean this particular light here, if it is still working. And if I'm to do that, first let me check this pin. You know, I said the essence of this video basically is to explain what I mean, what they mean by high logic and low logic, what they mean by hash signal. Now let me test this, starting from my first pin here. Let me keep the meter here. Here is fine. First pin here, what do I have? 5 volts. This is 5 volts, and basically this light and this keyboard is powered with 5 volts. Okay, the second pin, the same 5 volts. This second pin 4.9 volts here. This first pin again 5 volts. So this is the main supply here, and let's go for the third pin here. We have 0 0 0 0 0 0. This should be ground. So what do we have here? We have 2.7 at this fourth pin here. We have 2.7. Kí ni mo ń ṣàlàyé so far ń báyìí ni pé a ti ní first pin 5 volt, second pin 5 volt, third pin 0 0 0 volt, which means ó máa jẹ́ ground, and this place a ní 2.7 volt ní pin eléyìí. First, before doing anything, for the essence of video, all I will just do is I will supply ground and 5 volts without the last pin, and let's see what's going to happen. So I can just remove this. Mark, this is the supply pin. This is the supply pin. So if I should unlock here, so I remove here, as you can see, this is going to still be my supply pin. If I should turn, so here is going to be my supply pin and here is going to be my ground, the second to the last. So to do that, let me quickly tape this. Now let me inject voltage. Basically, essence I've explained low logic, high logic. I'll inject 5 volts and let's see if the backlight is even working at all. I'll calibrate this to my 5 volts. Basically, to inject 5 volts. I'm reduce it again to play safe. So this is my negative here and this is my positive here. So now I will inject this supply. We said this is our 5 volt rail and the second to the last pin here is ground. This is ground, okay, and this is the supply here. Do we have any lights? Let me turn this off and let's see. Okay, this is my 5 volt rail and this is going to be my ground. Do you see? Now there is lights here. Now there is lights. Okay, so now we've confirmed that the keyboard is working and the backlight is working here, and what we are going to do is we return this back to the motherboard. Turn this back to the motherboard. Don't worry, everything is safe. You'll be thinking I don't remove the keyboard. Don't worry, I'm playing safe. Nísìnyí tí a ti confirm pé backlight wá ń ṣiṣẹ́. So now let's go back to the main topic of this video. And let me set my probe. Okay. Now what could be the only problem here? The only problem that will make this not to turn on if this is working when I'm testing direct is when there is a signal. This is the first pin 5 volts, the second pin 5 volts, the ground pin, and the last pin here which is 0 volt again, 0.0 volt. The only pin that could be controlling it is when we have controlling pin, probably high logic and low logic. So now I told you earlier on, I said in the previous board we have this F10 to be the keyboard light pin. So I'll use the function to control this, and when I control, do I have the light? Yes, I have the light here. If you come here, do you see that? Do you all see that? Now we have the backlight, and if I place it under the keyboard, as you can see, we have the backlight. Another thing again, let me press it once again. Let's see, or let me turn this light off. Now you can see, let me press it once again. You see, it is more brighter. Off, brighter, off, on, brighter, off. Now we confirm the two last pin to be 0 volts, right? Now let's brighten everything. This is the full brightness, and let's check the last two pin, and let's see what is the voltage you are having there. Now I've turned on my lights. The keyboard light is still on, and let's check the last pin. Let me start from the second to the last pin, which is the 0 volts. I said it earlier on. This is the ground pin, and the final pin here, which is the third pin. What do I have here? I have excuse me, I'm placing my probe. 5 volts, okay. Second to the last pin, 0 volts, and last pin here we have 0 volts here, 0 volts here. This days was coming higher voltage, but well, let me keep it at the middle lights, which is FN, off, and middle. Okay, now let's check again. The last pin we have 1.3 here. We have 1.3 that was coming 0 volt before. Okay, now let me do this again and off the light. Let's see what we have there. I've off the backlight here, and let's come back here. We have 2.7 volts. 2.7 volts. So kí ló ń ṣẹlẹ̀ yẹn? Ìgbà tí iná yẹn tó wà off, nínú readings yìí we are getting 2.7 2.9 thereabout. Ìgbà tí ó máa on ó wà ní 0 volt, which means the time this keyboard light is going to activate, it is going to activate with low logic, which means if this voltage here, this last pin, if it should remain at 0 volts, there will be keyboard light. There will be backlight at the keyboard. If this pin remain at 0 volt, that happens to be the arch signal. So if this is coming, for instance, if I have it in the schematic as stores, probably KB LIGHT lights coming with a single pin like this, and it is written here ash, it means it will activate this keyboard light only when this 3.3 volt is at low logic here. So it will activate at this stage. So at this stage here it is going to activate, at this stage here it is going to deactivate. That is the essence of this arch signal. It could be a single pin, but this ash is trying to tell you that this particular pin will activate that place when this signal is at low voltage. Now let me prove that again, once again. Now before, no backlight now. Now let's see what is the voltage on that pin. On that pin here I have, let me bring this closer. On that pin here I have 2.7 volts here. As you can see, 2.7 volts on that pin. Okay, now let me turn this on. F10. Okay, this is on. And another one here on this pin again. I have 1.3, and let me turn this to the fullest option here. F10, where is it? F10. Yeah, I have the F10 again. So now let's check again. Now this is 0 volts, which means this thing is activating on low voltage. Do you see that 1.3 there? That 1.3 there. If you are tracing on motherboard, probably for instance, that section that needs higher logic and it's not getting enough higher logic, so it is not going to be working proper. It might be working in some case, and it might not in another case, and it might be working abnormally, basically because the requirement for the higher logic is not fully fulfilled. And at the same time, the same signal can still be used to control probably the maximum, minimum and maximum of something. So that same signal can still be used. So if you are dealing with a section that you are expecting probably yes or no answer, probably high or low, if it is going to be high, you need it to be very high, as in the logic has to be high to achieve the full functionality of that section. And if it is going to be low, you need it to be low, as in totally low, probably 0 volts, 0.0 volts thereabout, or 1 volt is not bad, is not good. Reason because, as you can see here, when the voltage is at average volts, here, let me show you. When the voltage is at average volt, what's going on? The keyboard light is turning on, but is not as bright as when it is at full option. Now let me do this. F10 off, F10, this is half of it, not too bright. And now let's come back here, 1.3. Now reason why you are having the voltage is because there is element of the switching, but it's not complete, so it is not giving you the full backlight you want. So basically the signal is used here to regulate how much it is going to be bright or not, because that is what is needed here. But the basic concept you are trying to explain here is whenever it is written ash and it is written pure, what is it called, pure labeling without any hash, it means it is going to activate on higher logic, and if it is written with hash, it is going to activate with lower logic. What much I basically that is all back and front. Tó bá kọ any signal tó fi hash sí, nǹkan tó ń try àti explain ojú wípé ó máa activate tó bá wà ní low logic. Tó bá filẹ̀ plainly tí wọ́n kọ bí for instance ACOK tó kọ̀ akọ ACOK, ó means pé ó máa activate tí voltage yẹn bá ti high. Nǹkan tá a wá ń try àti explain by pé case eléyìí wọ́n fi regulate ni, that is tó bá wà ní 0 ó máa off, tó bá wà ní high pátápátá ó máa high to the maximum functionality. Tó bá dẹ̀ fi sí average voltage ó máa ṣe kí ni, ó máa fún wọn ní average output, torí bí ìgbà tí mo bá power ẹ̀ pẹ̀lú full 5 volt àti mo power ẹ̀ pẹ̀lú bí 3 volts kò ní bẹ̀rẹ̀ dáadáa. The same thing goes on with fan, only fan náà máa fi regulate speed ẹ̀. So tí ó bá ti ń activate, tó bá jẹ́ pé high logic lọ lò fún, high logic lọ máa lò ní fan náà basically, tó bá jẹ́ high logic lọ máa lò fún, tó bá ti high tán fan náà máa ṣiṣẹ́ to the fullest. Tó bá jẹ́ low logic lọ lò fún, tó bá ti low tán fan máa ṣiṣẹ́ to the fullest. Tó bá dẹ̀ jẹ́ pé in between ló wà, so ìgbà yẹn ni fan máa spin at a very low rate, wàá kọ́ mọ̀ kò ń yí, kò ń jẹ́ pé wọ́n máa sáré gan, kò dẹ̀ jẹ́ pé kò lè sáré rárá. Onírú ṣe, ọlọ́bẹ̀ ṣe, onípọ̀nmọ̀ ṣe, olóyìnbó ṣe. Round there off.